Welcome to Heavy Wireless, a podcast that's part of the Packet Pushers Podcast Network. And today we're talking about a thing. It's a thing that's really hard to describe. So I've brought with me Artmiz from LATYS Company to talk about this new idea of how you take RF and you boost it, you amplify it, you direct it, but without using layer 2, layer 3, layer 4, any of those things that we're used to. So Artmiz, glad to have you with us today.
Hi, Keith. Thank you very much for having me. Can I just fangirl for a second before you start? You have no idea how excited I am to be on your podcast. I mean, just having been to my first WLPC was an insane experience, but then to be on your podcast, it's something else. Thank you very much for the invite, Keith.
Oh, no problem at all. Glad to have you here. I met you over a year ago at a conference, and you were presenting something that was a unique idea, and it literally took me almost an entire year to figure out how it works, because it's so unique in our industry. We all are used to having an access point that takes a wired cable in, it takes a frame and sends it, layer 1, 2, and 3, and we know how access point works. We also have something like a repeater or a range extender you might use in someone's house that listens to Wi-Fi, decodes the frame, repackages the frame, and sends it on its way. A lot of people's mesh in their homes use the same thing. But you have a solution that doesn't use electronics. Well, I can't even say electronics. It doesn't use frames or decoding or any of those things, and yet it gives you some advantages. What do you call it, and how does it work?
So the product is called the LATYS Focus, but the category of the product doesn't really have a name yet. Before you hit record, Keith, we were trying to brainstorm and come up with like a term for it. You're right. Repeater, extender, all of those don't do the product justice. Those terms have meaning already. So we're trying to introduce a new line of product that is over the air, that is active only in the sense that you need to provide power to the device. It's not active in the sense that it is, touching the signal in any way. It's not demodulating the signal in any way. It doesn't even know that it's sending a Wi-Fi signal. And then the other advantage that it has is that it's directive and it can amplify the signal. Now, there's another feature to it that we're using as an advantage, and it's that it's unidirectional. So it can only send a signal from one side to another. It can't do the reverse at the same time. And it's been designed to not do that. That's so that we can create non-reciprocity in the network and in turn create intelligent spatial multiplexing in the network. Now I'm throwing some more big words that we can talk about more, but basically, what we want to be able to do is to separate the transmit and receive so that we can do to transmit what we need to do to it so that the packets get there. And we can do the same thing to receive without affecting transmit.
Okay, so let's back up and talk about the base level of the technology. It kind of has an inbound antenna, so it listens. It has an amplifier, so it takes the signal that received and then transmits it out a directional antenna. So it's an in antenna, amplifier, out antenna, directional, one way only.
Exactly. Both input and output are directional. So we accept the signal in a very directive cone. We transmit the signal in also a very directive cone. And then we amplify, basically boost the signal as it passes through our device. But because we're doing all of this at physical layer, this is all happening almost instantaneously.
So it doesn't really matter what modulations used. It doesn't matter if it's Wi-Fi. It could be halo. I guess it depends on frequency. Anything that's in the frequency, it forwards automatically.
Exactly. And if we were to design the physical structure for a different frequency, it could do the exact same things for that new frequency.
So what frequencies have you designed it for so far?
So we have designs for all across 5 gigahertz for now.
So the whole 5 gig band. And
exactly.
So if I'm running a non-Wi-Fi signal, it does the same thing. It hears the signal, amplifies it, sends it on its way. You'd mentioned spatial streams and MIMO. How does it handle because those are also radio waves that are coming in and they're bouncing and they have some spatial stream characteristic on the way in. Does it change that on the way out?
the focus device itself has no idea that there's anything other than just a simple wave coming in, right? So it doesn't know that there's, MIMO happening in the system or not. All it can do is that it can help with the bouncing around of the signal in the network, because it can basically work like a lens in the network. So it can capture the signal from an area, amplify it, send it out. So if, the MIMO signal you're sending through happens to be in the cone of acceptance of the device, then it gets through. And if it's not, then, it's over the air happening, not going through the device, if that makes sense.
One of the things you call this was a relay. And that sounds like it takes something in and relays it and sends it out. Good definition. How would someone use this device? You mentioned it's one way only. I'm guessing if you put a pair of them together, because we need two-way communications with Wi-Fi.
Yes.
So let's think of them as a pair, but we can focus on just a single one. A radio wave comes in, it gets focused, amplified, and sent on, including all its characteristics. How does it do that without any form of demodulation?
It's a physical layer device, right? It's just seeing a wave come in. That wave can be Wi-Fi, it can be Bluetooth, it can be any other RF signal that's going through. I just remembered something when you were talking about that we need we can't use just a unidirectional device. We need bidirectional signal going through. Is that once we start talking about use cases, maybe this will make more sense. But there are certain use cases where we could potentially use just one device, even in Wi-Fi, just one focus, even in Wi-Fi. And one of those examples is, I think, a demo that maybe you saw earlier this year where we have a power mismatch in the network between the AP and a bunch of IoT devices, somewhere in the network. The IoT's devices are low power. They are, not putting out, a huge amount of signal, but then the AP, on the other hand, is screaming its signal. So this power imbalance can then be somewhat adjusted with just using one focus pin. So we place one in a direction where we are only improving uplink. And so we bring balance to the network. To the force. Yeah, I stopped myself for a second.
It's okay. I think our audience will get that reference. And that's a good example, that it doesn't necessarily need both. And we do have Wi-Fi situations where there are power mismatches, and that can be a solution. In that example, would you put your focus near the IoT or near the AP? I would think closer to the IoT would give you that boost rather than take the super small signal that's by the AP.
Yeah. You could honestly do it either way. All you need to do is to flip the focus the other way around if you wanted to place it near the IoT devices for it to help uplink, or you keep it in that same orientation and then just move it closer to the AP. And then that would still help uplink, although the signal that's being received at that point is not strong enough. If our device wasn't in the network, right? If our device wasn't in the network, that was why there was a power mismatch, that the signal wasn't strong enough, the one that was coming from the IoT devices. In the tests we've done, the best locations are either close to the cluster of user devices that you have, and by close to, I mean just in the general vicinity, or close-ish to the AP. As long as you are not, more than 100 meters apart between the two devices, and then you put it right in the middle, because right in the middle is theoretically the worst place to put them. Put our devices. But as long as you're keeping it in general vicinity of your devices or of the source of your signal, then it'll do its job.
We're pausing the conversation for a brief reminder that Packet Pushers has a Slack community, and you can join for free. Whether you want to ask questions, share tech tips, swap stories, or just connect with other engineers, the Slack community is a friendly, collegial space. Check it out at packetpushers.net/Slack. That's packetpushers.net/Slack. And now back to the show.
Well, let's get to some details. You mentioned directionality, cone of acceptance. So we understand access points. We understand antennas, directional antennas. So on a directional antenna, they have a dB gain, and they have a usually angle of where they're 3 dB down, the 60-degree antenna, etc. What is the LATYS Focus's tech specs in that category?
So we have a 60-degree cone of acceptance and a 60-degree cone of transmission. Those two are design parameters. We can make it wider, we can make it more narrow so that it becomes more of a pencil beam instead of, the cone shape that it has today. Over the air, we can provide somewhere between 10 and 15 dB of gain. Calculating the exact dB of gain through the antenna is different from over the air for the signal. So I'm giving you the number over the air. And in general, you don't want to be in the radiative near field of whatever your source is, whether it's the user side or the AP. You want to try and be somewhere between, 2 meters-ish mark or a little bit further from the
So you would place this
source
near your IoT devices and conservatively pick up a 10 dB gain that the access point's going to hear.
Exactly.
And since the access point can crank loud, the IoT devices hear it, and we're good to go. So is that 60-degree symmetric, 60 by 60?
So it is a 3D cone, and I know your audiences can't see me do this with my hand, but it is the 3D cone. So yeah, you've got 60-degree in elevation and 60-degree. Is this azimuth?
Yes, very good.
Yeah.
Yeah, and we're used to, you can buy antennas that are symmetric, like 60 by 60. You could buy 15 by 180s. There's all sorts of combinations.
Yes.
And you could probably design yours to meet that need if there was a specific need.
Absolutely, yes. So we have now moved towards a more square-shaped for our antenna. But, if we make it a little bit more rectangular one way or the other, we can adjust all of these angles.
So what's the physical size and shape? What does it look like, a focus? You're going to have to do this without a picture.
Yeah, without a picture, over audio. You saw me looking around my office to see if I could hold one up, but that doesn't work. So it's basically the size of maybe a 15-inch laptop. It's about, I think, 2 centimeters in depth. And then the width and the height are about the size of a small laptop. And
what's its power requirement?
So the current versions that we are testing are powered through a USB-C, and you can power them with a regular cell phone battery pack, and it can last you, up to 24 hours. They technically consume about 4.5 watts. So
very
depending on how big your battery pack is, it can cost you a lot.
But the lightweight draw. And they do not have an Ethernet port.
They don't. We, in fact, decided not to even put one in because where would we connect it to our antenna?
And so there's no configuration. There's no web interface. There's nothing you can do. There
is nothing.
When you buy it, it's done. It's just there.
It's kind of both an advantage and a disadvantage, I would say, because it should be super easy to install. The user guide is basically saying, place it where you need it and then plug it in. And at the time when we wrote our user guide, it had an on-off switch. We're also eliminating the on-off switch. So when you plug it in, it'll just be on. And it'll just work. The reason I say that it might also be a disadvantage is because there is no interface. There is no way for you to look at the functionality of the device, to look at its impact on the network. What you could do is to use a third-party tool that already exists, either a heat mapping tool or to look at the performance of your devices, of your end user devices, to see how they're doing. But we don't provide we don't even ourselves have any kind of access into the device because it's not doing anything.
It's doing a lot.
Not that it's not doing anything. It's
just doing that.
Yeah.
How do you mount? What are the mounting options? If it's this, 2 centimeter by 15 by 15 kind of square thing, is it mounted with like a tripod mount or there's clips? Can you ceiling mount it?
Yeah. So you can mount it around the edge of the device. We have three different mounting points around the edges of the device. They're your typical tripod screw mount. And then the other side of it that you could either install on a wall or a ceiling that we provide are basically a ball and socket joint, so that you can turn the device around. You have 360 degrees of freedom in moving the device around. So if you wanted to kind of imagine it, it would either be kind of like hanging from the ceiling like an exit sign, or sticking out of an aisle, again, maybe like an exit sign, or you know what I mean.
Yeah. You mentioned putting on a wall. We don't normally think of taking our Wi-Fi devices and mounting them directly to a wall. Well, sometimes we put an access point like in a gym on a wall and it's sending the signal out. Since yours is boosting the signal on the way through, if I mount it, if the cone of acceptance, the input side was that same basketball court, and I put it on a wall, it would send the signal through the wall to the other side.
Into the parking lot. Yeah, to the other side. It really depends on what your use case is. So one of the things that we realized pretty early on was that the way you design your network, the way you plan your network with a focus in your network is going to be different from how you design a typical network. And so you need to put some thought into where you're going to place them based on where you want your signal to go, because you basically have a device that can take your RF Wi-Fi signal and put it wherever you need it. So if you want your signal to go out into the parking lot from that basketball court, then you can place it on the wall and then shoot it out. But if that's not what you want to do with it, if you want to keep your signal inside the arena, then you need to plan your network differently. Then maybe you want to have the ceiling mount ones instead of the wall mount ones. By the way, they're the same product. You just the orientation in which you install them is going to be different.
Well, it sounds like a nice time to segue into what are use cases for this? I like thinking through them. What are the ones that Lattice has come up with?
So the IoT use case, the power mismatch thing that I was talking about a little bit earlier, so that's a new one for us. That's a new use case. But the typical warehouse, industrial, factory type of space, that type of market is our entry market. We're trying to bring connectivity to radio hostile environments, to places where, yes, you're going to plan for coverage everywhere, but inevitably you're going to end up with either dead spots or with areas of poor connectivity than you would like for your devices to have. This is more of a brownfield, I guess, use case for the product. And then you could have a greenfield use case where you're building a brand new warehouse or a brand new industrial complex, and you're going to be using LATYS Focus devices in the network. And so what you would do in that scenario is that you plan your network knowing you're going to need some access points, because that's what's going to provide your type of Wi-Fi, basically, because all our device does is to take the Wi-Fi that you have, and then it basically replicates it into the network and focuses it where it needs to go. And so you have your APs and you have our devices, so that you can plan a network that either uses less access points or uses them more efficiently. And you use access points more for capacity than you do just for coverage.
Well, I can think of a prime situation where I've had buildings with elevator shafts, sometimes a whole block of them in the middle, and it's really tough for an access point to get through 3 or 4 or 5 elevators. And so behind the elevator, if we needed coverage, maybe in a janitor closet that's at the end, there's no way to get that coverage without adding an extra AP, or around a corner or behind a stairwell where there's some really heavy RF attenuation. Instead, I could just put a focus where there is coverage and aim it into that area. Well, in this case, I would need 2 of them, one to listen back from the client and one to send it. But you could use this to turn a corner.
Yeah, absolutely. You can use these devices basically, like I was saying earlier, to just control where you want your Wi-Fi to go. If your janitor's closet needs Wi-Fi and you can't provide it other than by putting another access point, Well, you're only really using that access point in that scenario for coverage, right? You're not adding it because you need extra capacity in the network there. You just, because of the elevator shaft, you just can't get the signal that way. So if, somewhere between 10, 15 dB brings the signal there, then you can put a pair, one for uplink and one for downlink. Now, if you need more boost than that, then you can just use another pair along with it. They add up. So you can
put them in serial format and just get 10, 20, 30 dB boost.
Exactly.
Oh,
now, we don't know what the limit is. We haven't reached the limit yet. The most we've tried is to put 3 for uplink and 3 for downlink, and we've been able to triple the advantage. Now, I don't know if the math will continue to go forward.
Well, speaking of math, one of the math issues here is in that previous example, a place where I would have to add an access point. That means I'm going to have the cost of the access point, its install, its cabling cost, its switch port costs. How does a LATYS Focus, or a pair in this case, compare to the price of an access point?
Yeah, Keith, you covered all of the expenses of an AP except the now annual fee that comes with it.
Yeah, there is licensing fees and support fees, yeah.
Yeah, for sure. So support fees, maybe we'll have those too. I don't know yet, but no, the prices aren't even comparable. We're talking about a few hundred dollars for a pair of LATYS Focus, as compared to, probably upwards of $1,000, including all of the costs that come with having to install.
Or more, depending on which access point you're working with. That $1,000 is pretty low.
More.
I mean, I've had sites where just the cabling costs more than that. And since these are fairly easy to install, there's pretty low install cost. They do need to be powered, but that can be powered off of, I'm assuming if we had DC voltage, you could take DC voltage because it's just USB-C, or a little USB-C brick put in someplace.
Exactly.
So very, very low install cost. How about aesthetic-wise? Have you found, a lot of our customers have this aesthetic issue, and you said it looks like an exit sign. I've had not a single customer complain about exit signs, but the majority of them complain about access points. So is this one of those ones that we're going to have to take to the aesthetic police?
So what we were trying to do with the aesthetic design of the product was to make it blend into the background as much as possible and to not look like you have another device in the space. We didn't design this product for consumers, right? We designed it for an industrial market. So, mute colors, a surface that's pretty flat, that sort of thing. But if, this, Keith, we're pretty early on in our customer discovery and sales path. So if we find out that the aesthetics are a big driver, then obviously we can change how it looks. But it's a pretty low profile device, I would say.
Adds an extra 10 dB and focuses it. Now my mind's starting to wander about all the places I've wasted access points where I could have just put one of these in because all I needed was that coverage just around a corner or in a building. And from the aesthetic standpoint, I was thinking, if I wall mount it, is it paintable?
Oh, that's a good question. It can be. I won't get into the whole effects, depending on what kind of paint you use, it's going to affect the RF properties and all of that. I won't get into that. But
and we already have those. We've solved those in the access point realm. There's some paints that work, some that don't. There are vendors who actually sell skins that are RF neutral that you could wrap around something. So I'm sure they could make a skin for this as well.
You're giving me a lot of ideas, Keith. Thank you.
Oh, good. That's the point. So what are some other use cases? I can see you had a warehouse and you just need to get an extra 50 meters out of it without adding another AP because you don't need a capacity.
Yeah. One of the other interesting use cases that is a new use case to us is a Wi-Fi emergency. So, when you have a switchboard for a part of your warehouse just go down for whatever reason, but you still have connectivity in the rest of your warehouse, you can basically allocate capacity from somewhere else in the warehouse over to the area that the Wi-Fi went down until the deployment team has time to go out and fix the issue with the switch.
I don't think I've heard the term Wi-Fi emergency before, but I kind of like it. So if we had a couple of, a pair of these in stock and there was an outage, you could just have the janitor go put them up because they don't need much other than and if you can aim them with a little ball and just rotate it around, about anyone could do that and say, I need to get in fact, with two of them, you could get coverage to almost do a U shape and turn around a corner.
Exactly. You can do all sorts of geometrical shapes by putting them back to each other, and then either have the signal do a U-turn or, go down a stairwell or up an elevator shaft. You can do all sorts of different kinds of configurations with them. Now, you mentioned the thing about not really needing any kind of expertise for the person that installs it. Absolutely. Like anyone who can plug a phone into, a cable, can plug this into either the wall or a battery pack. And then anyone who can also put a camera on a camera mount would be able to put this on a tripod and then bring it out for that Wi-Fi emergency use case example we were talking about.
Sounds like something I need to have in my toolkit just to carry around. Well, Artmiz, thank you for spending the time talking to us about this new, I don't even know what we're going to call it yet, but a way to boost a signal and focus in an area. You want to take a minute and tell us about LATYS and give us your elevator speech?
LATYS is a wireless networking company. We're on a mission to improve wireless connectivity. Our proprietary technology is how we're changing how wireless networks are designed. What we're basically doing is to add space as a resource on top of time and frequency. And that way we can create networks that are more reliable, they're lower cost, and they have a positive environmental impact, which is a really important value pillar for LATYS as a company. The first application use case for the LATYS Focus is industrial warehouse connectivity, where we can bring faster, stronger, and more reliable connectivity. Thank you, Keith.
And just to reiterate, this doesn't need Wi-Fi. Anything that's in the 5 gig range will benefit from this answer. And it doesn't really matter which channel it's on. You don't need one specific per channel.
So once we have the other frequency ranges, it wouldn't even necessarily just be for Wi-Fi 5 gigahertz or any protocol that's in 5 gigahertz. It could also work for other frequency ranges. But for anyone that wants to try them today, we have 5 gigahertz versions ready to ship. Sounds
good. Any obviously, I'm guessing you're working on 2.4, the 2.4 range, 2.4 to 5, 6 gig. Anything in like CBRS range and the 3.5 range?
So, in fact, after 5, we want to start working on the 6 gigahertz range first before we work on the 2.4, because we've heard enough feedback from the market saying that we want to deploy more 6E networks, then we want to deploy 2.4. So we want to make sure that we have the product that can support that market before we go to a legacy frequency, basically. And then
and 2.4 already has a 6 to 8 dB advantage over 5 and 6 to start with.
Exactly. 2.4 doesn't really need a solution like this as much as 5 and 6 do. And then you brought up a really good point, Keith, about the CBRS or just the cellular version of this new product line for other use cases, wide area networking use cases, I guess I could say. And the answer is yes, but we are going to kick off our Series A fundraising soon, which will then give us the funds where we can start exploring all of these other frequencies.
Well, we'll add links in the show notes to both your email as well as the LATYS website. And I appreciate your time. You've been listening to Heavy Wireless, part of the Packet Pushers Podcast Network, and we look forward to talking to you in the future.